But when it comes to physical AI, the inputs are heterogeneous. Like we can have multiple types of sensors. Yeah.
So
Yeah.
we have our buddy Alfred.
So language models are getting very capable on the reasoning domain.
When we are learning, there was no subdomain called physics import machine learning. But now we can see more accurate results when integrating these physics logics into models. And start small and build applications and iterate fast.
Hi everyone, welcome to the last episode of the Tech Talk series conducted by ITV. Today we are at Zone24x7 and we are planning to dig deep into the physical AI domain. I'm Kanishka Wijayasekara from ITV. So to start off, we have Kanishka Wijayasekara, who is a solution architect at Zone24x7. So he has been having industry experience for like a decade, and today we would be asking a few of the tough questions in physical AI. Kanishka, can you give us a briefing on what physical AI is and how it differs from traditional screen-bound AI systems?
Yeah, sure. So, like we know that in a day-to-day perspective, we deal with virtual AI, right? Like, so in that case, mainly what we look at is like we get an input, we process it, and we output. In contrast to that, in physical AI, the difference is if I take this as an analogy to humans, the common intelligent thing that we usually deal with. So in that case, as humans, we get inputs from multiple ways. Like we can feel the touch, we can see things, we can hear things, and there are multiple ways that we can get inputs, right?
Exactly.
And also we process it, and most importantly, we make an act on the environment.
Yeah.
So in contrast to just input processing and output, which is analogous to the virtual AI systems, in physical AI systems, the difference is it senses the environment and it perceives what it sees, and it makes an actuation on the environment. So that's the main difference between physical AI and virtual AI that we usually deal with. Yeah, so that's in one way, that is how we do it. And in contrast to that, there are multiple things that like if you say that in virtual AI, that what we usually deal with, we deal with a keyboard and maybe a mic and a camera and a screen. That's all we have, right? And a speaker maybe at most. But when it comes to physical AI, the inputs are heterogeneous. Like we can have multiple types of sensors, like it could be IMU sensors, it could be RFID. There are tons of sensors that we cannot actually limit into a particular scope. These are the things that we are going to have. And at the same time, the outputs, it's going to be a lot of, the variations are going to be very high, because we'll be having motors, we'll be having, robotic arms and speakers, multiple ways that we can give outputs to the environment. That's the main difference between virtual AI that we deal with and the physical AI.
Yeah, wonderful answer. So Kanishka, as you said, like if these physical AI systems are behaving like humans, capturing so many, so there would be scenarios where it has to capture so many data. So physical AI is where like we also integrate generative AI. So it can be having multiple modalities, heterogeneous data, numeric telemetry. So how do we deal with them, and how do generative AI models that are currently available could process all these modalities? Do you have any sort of a solution for that?
Yeah. So I'll build up this solution like this. So as an example, like if we take a robot, right? If you take a robot, in that case, what usually happens is we get a lot of information from multiple sensors. It could be LiDARs, it could be cameras, it could be sensors. We are getting all this information in. And as I mentioned in the early answer, so those can be different, the formats of the information can be in different sensors. So that's the main challenge that we have, because in the traditional physical AI systems, what we do is like in AI, we have two different areas. Like first one is a learning based AI and the other one is cognitive based AI. So at the moment, the primary component to the physical AI is from, I would say, logical information, right?
Yeah.
So in that case, what we do is we get all the information and we do some calculations inside and we take a decision upon that. Okay.
So we have our buddy Alfred. So he would be offering us coffee.
Thanks, Alfred.
Thank you, Alfred.
Perfect. Yeah, so I was telling you that, so in that case, usually what we do is we deal with logical and rule-based systems. We get a lot of sensor information to the robot and we take decisions upon calculations. We calculate costs and take decisions, right? And the thing is, like when it comes to generative AI, it's very cool. Like we know that we can do a lot of things.
Yes.
Generative AI is totally smart, right? But still, there are some cases in physical AI systems that we have to have the auditability, right? We have to know that this is repetitive, and also we can make sure that the same set of sensors is going to give us the same. It should be more like a deterministic system that we are expecting. So in such cases, I would say still the physical AI is relying on cognitive based systems, like I would say rule based and logical systems, but that's evolving. Of course that's evolving. You know that like a couple of years back LLMs were just text based input and output, and then it became an multimodal. It brought in they brought in the multimodal concept, and the latest thing is they brought in the reasoning capabilities as well, which is getting very closer to our purpose as well, like where we need to make a decision and be clear about how we took the decision on the information that we get. So with all these things, I would say generative AI is getting closer to being used in physical AI directly, but at the moment right now I would say there are some things like I would say autonomous navigation sort of things. We could still rely on logical systems where we do some cost calculations and take the decisions. Like as an example, if there's an object or an obstacle right in front of the robot, we can decide okay how to do, like whether I should turn left or right depending on the cost that is going to cost me. But in future, with the the evolvement of the reasoning capabilities of the language models, I believe at some point we'll be able to offload those kind of capabilities also to LLMs. Yeah.
Thank you, Kanishka. So I have another question. So when we come to this deterministic flow, so you said in like instead of having Gen AI, still it depends on cognitive and like some sort of a deterministic manner. So by incorporating Gen AI, we can make some non-deterministic decisions as well. So when integrating these Gen AI models and all to the prevailing cognitive based systems, we come across these latency issues, right? So what is your concern behind that on applying Gen AI into cognitive systems?
Yeah, very good question. So in that case, in any intelligent system, I see three main areas, right? Like that is like it should be smart, and it should be reliable and accurate, and the third one is it should be fast, right? So all these three things are very important when it comes to any intelligent system. But specifically when it comes to physical AI, I would say speed also becomes a key role, because in any other virtual system that we deal with, speed may not cause any damage, right? But when it comes to physical intelligence, specifically when we are talking about robots and moving parts, the decision making has to be very fast. Like when we see some obstacle right in front of you, the robot has to stop. There's no option in that. You can't think and stop, right? So the decision making speed is very critical when it comes to physical systems most of the time. I wouldn't say that everything, but in things like robotics, it's very critical. I know that now LLMs are evolving and we are getting the capability to run them in the local systems, and it's getting there. But still, there are many things that we can use generative AI and LLMs language models in robots. There's no doubt about it, like understanding the request from the user and also making high level decisions like what to do next and all these things. But there are two things, like first one is that what I mentioned, like taking overall decisions, what's my next goal is, what should I do next, what's the request from the user. All these things can be totally handled by LLMs, there's no doubt about it. But there's another thing about making immediate actions, like avoiding an accident making navigation turns, stopping right in front of an obstacle. So those things, at the moment, I think we are still getting there with LLMs to make it faster, because I wouldn't say that model with a proper reasoning capability still is not runnable in one of our computers that we use on our robots. So it will get there, but at the moment, if we are to send that information, sensor information to a cloud and get the information back to the robot to stop the robot, I would say it will be a bit late. For the moment. So my thought, my opinion on this is we have to use this in combination. All the nice to have features like deciding the goals and all these things, we can use generative AI, LLMs and all, and mission critical decision making on making navigation turns and making any actuators move, those things, let's keep it for the cognitive AI for the moment, and later move on to the LLMs.
Nice explanation, Kanishka. So as you talk about this hardware, so I would ask this question so we have this hardware cost constraints, right, in Sri Lanka. So in terms of embedding, let's say, a small language model and all, still we come across this cost. So what is your concern when we mark this trade-off between the accuracy, performance and cost?
Okay, so there's a mix of this, like where we have to get the small language models run on our components and what we can do with it, right? So at the moment we have also tried with small language models to deliver certain use cases. In such cases, in robotics also, and robotics and physical AI, like as an example, say that we have a home automation system, right? In that case, that is also a physical AI system, physical AI, right, where we get an input from, could be vocally or by any other input like set of sensors, and making an actuation over that. Like say that we identify the sunrise is there, and I have programmed or told my AI or home assistant to open curtains when the sun rises. So that's a physical AI system. So in such case, using a small language model to cater that capability without relying on a cloud cloud large language model is an option. Like still, we have to see where the benefit comes in and if the cost is justifiable. Right. So the use case, we have to make sure that the amount that we have to host even a small language model, we have to justify that cost is right for this particular application. I mean,
so it can be like in terms of whether this provide the right accuracy that is needed, and whether
the cost is going to involve. And we have to make sure that if we actually need a small language model here, right? Like say that if our the requirement is pretty simple, we don't have to have an overkill for that. So making the right decision, looking at the use case and the cost and all these things is the key in using generative AI, because you know that when there's a trend that we tend to use the cutting edge technology for everything, but we have to what we have to ensure is like we have to choose the right technology to the right point. That's my view on that one.
Thank you, Kanishka. It was a really interesting solution for the question I asked. And so as a nutshell, what I took from this was like if we were to integrate Gen AI to cognitive systems, we need to consider that whether it is related to reasoning or based on the fact that really we are going to go along whether to use it or not use it.
Yes, and also most importantly, large language models are getting very capable on the reasoning domain. So I'm very hopeful to see in the next couple of months, I would say, like or couple of maybe by next year, I think we should be able to see very good models with very good reasoning capability that we can directly use with physical AI, and where it can take decisions with robust reasoning, where we can justify at the end of the day. The reason is like in contrast to cognitive systems, like in cognitive systems, what we can see is like we can clearly see the audit and see like what happened, whether it is a sensor error or what happened. Like if it was not a sensor error, then it's really difficult to see a different way, because it's a logic that we have. If the cost is this much, you should not do that. If the cost is that much, you should do it. So simply, if we can get a crystal clear decision making which is justifiable, I would say, because decision making is not always deterministic, right? Like that's why humans are different, and we call us intelligent. Like from time to time, our decision making processes are different, but most of the time it's justifiable.
Uncertain parameters, non-deterministic.
Exactly. So with the involvement of language models, with their capability to handle heterogeneous data and the reasoning capabilities, I'm very hopeful to see a huge bump up in the physical AI domain as well.
Thank you, Kanishka. Okay, so we have another resource person from Zone24x7, Mr. Ishara Neranjana, a machine learning engineer with 3 years of experience. So, Ishara, the question for you is, what's driving traction in physical AI? So, we see that breakthroughs in models like archetypes Newton. So, can you give us a more broad view on that?
Yeah, so I will start like the answer for this like this. So, if you look at the beginning, now we had the transformer model, right?
Yeah.
Then there were some models, large language models, and then we had multi models. Yes. So we have that vision capabilities as well. Then we had vision language models. After that, we came to vision language action models. Yes. We call them as VLA models, right? So for your question, what is the traction? Now, if we look at this in a broad area, we can see that now we have embodied intelligence in these models, and we have hardware that are capable running these models in edge, right?
Yeah.
And also now we have the democratized. Now we have open source models, open source frameworks that you can use for building these intelligence systems. So I think these drives these physical AI, and now we have more capabilities to do things in physical environments. And also now if you look at the latest breakthroughs, now you mentioned one, archetypes Newton, and also we have NVIDIA, Rook N1, and also we have from Google DeepMind, we have Gemini robotics, Gemini ER, that means Gemini embodied reasoning. So these models have reasoning capabilities as well as the vision capabilities, so they can run in physical environments.
So Ishara, how do we ensure the robustness and confidence in models when we integrate them in low resource systems? Is it like calibration, redundancy, or benchmark based parameters?
Yeah, that's a good question. So I think we need to depend on all three. So we need to calibrate these models, so in order to get better performance, as well as we need to have some fallback mechanisms. So we have some redundancy in our models. So if you are using these models in mission critical scenarios, you need to have some fallback mechanisms. So sometimes these models may not be accurate, right?
Yeah.
So you know that we have problems like hallucination.
Yeah.
So and also sometimes these, when you are deploying these models, sometimes these servers may be down, or there may be some problems. So in those scenarios, we need to have those fallback mechanisms. So we have that redundancy, and also when you are looking at benchmarking, it is very important one. So when you are selecting a model for a use case, there is no model that fits in for all use cases, right? So you need to select from the base model for your specific use case, and you need to select on the device which is you are deploying your models. And also you can deploy these models in cloud or on premise, so you need to decide on those factors as well. According to those factors, you need to have some fallback mechanisms as well as benchmark validations. So if you want more reliable systems in physical environment, so according to your use case, you need to decide on the benchmarks. So there are, if you look at for reasoning, there are different benchmarks. If you want for coding, there are some different benchmarks. So likewise, you want to select the best benchmark for your use case, and you need to rely on those three aspects of systems to get more reliable performance.
Thank you. So it was a good solution actually for that. And the next question would be like looking ahead, we see that physical AI being integrated with physics informed models.
Yeah.
So what is your concern on that?
Yeah. Now let's say when you're talking about physical AI, so you are building systems for physical environment. So we cannot ignore physics, right?
Yeah.
So now when we are learning, there was no subdomain called physics informed machine learning.
Yes.
But now we can see more accurate results when integrating these physics logics into models. So now we have physics informed neural networks which are performing better than traditional neural networks.
Yes.
So I think in future and at recent as well, so most of the people are using this physics informed machine learning to improve performance on these physical AI systems.
So Ishara, in countries like us, where economy is a bit challenging when implementing models and also into hardware, especially like we come across hardware constraints. So how would you overcome those challenges when it comes to embodied AI, edge AI, where we have to bring physical AI by incorporating models?
Yeah. So when you are looking at large language models, the question we have is the cost, right? So we need to have some powerful resources to host these models, or you need to use managed services. So when you're using managed services, you have to pay for the tokens, right? So in order to avoid these problems, we can go for small language models. Or now when you're looking at small language models, these models are distilled from large language models. So there are some smart optimization techniques that we can use to reduce the footprint of these models. So if you look at techniques like pruning or quantization and knowledge distribution, so when we can apply these techniques and reduce the model size. So you can run these models in low power devices as well. So and also from these small language models, if your task is not going to be a heavy reasoning, and so according to your task you can decide whether you can use a small language model as well. So you don't want to all the time go for large language model or a reasoning model, right? So according to your use case you can decide on small language models. So the countries like us, so we can use these models in low power resources, and so everyone can use these things and build some real world applications in physical AI.
Yeah. Thank you, Ishara. So Kanishka, can you tell us few things about how physical AI is being applied in industry and how these embedded systems and edge AI works?
Sure. So basically, specifically, I'll bring the context to our company, Zone24x7. So in that case, we have been in the AI industry. I think I would call us early adapters because we have started robotics applications back in, I think, 2014, and we started on deep learning based things in probably 2016, I think, 16 to 17 era. And starting from that point, we have been trying to provide the best solutions to our customers. So in that journey, we have seen the entire spectrum, the journey of this AI being evolved, right? Like starting from the very basic rule-based systems, and then machine learning models with very low capabilities, and then moving into convolutional neural networks and vision AI, all these things. So in this journey, we have seen the clear evolution. So as few examples, in physical AI particularly, I would say in automation side, specifically in the industries like retail industry, warehouse and factories. So all these industries are adapting, they have been adapting physical AI for quite some time. But the thing is, the intelligence level it gains with the evolvement of with emerging all these large language models and all. And in that level, I would say starting from the robotics, and then we have done few projects on computer vision, because we know that computer vision also falls into physical AI, because we are getting direct inputs from the environment and generate analytics on top of that. And moving ahead of it, we usually deal with RFID systems. Now I have a classic example for this one. Now we know that we have RFID systems, traditional RFID systems, which is a heterogeneous sensor platform that we have. We get a lot of information from different sensors in that case. And the good thing is, now we have been able to integrate these capabilities, the vision AI that we have, and the RFID products that we have with our AI agents. So powered by LLMs, like we can virtually interact with these AI agents and get the work done from these our physical systems in the camera systems and RFID systems, all these ways that we have evolved that things. And in addition to that, if you are moving away from that physical AI area, now we know that LLM based applications, AI agents have been the talk of the town, and still there have been some issues with data privacy, and people are a bit concerned, though they are not clearly, there's no issue on that indicated on that, but still, people are concerned about the data privacy and all. But with the emerging of the possibility of self-hosting or locally or having dedicated hosting for your LLMs and ensuring that your data is not shared with anyone else, there are more opportunities being opened up. I think Ishara can give more information about like how we can utilize, because we have done a lot of research on self-hosting LLMs and using small LLMs to cater small applications where the requirement is sufficient from a can be catered by a small language model. I think Ishara has more experience with that.
So Kanishka, even I saw that bot with RFID, and I think they would also see it. So the next question is like how students in Sri Lanka and engineers who would like to come into this domain would work on or get a step on.
Right. So this same question even I had when I'm starting my career, because as an example now, in physical AI, in contrast to the virtual AI system that we deal with, the problem is hardware, right? Like that's a luxury that most of us can't afford when we are when we are undergraduate or when we are right after our university. So this solution. Now, most of the physical AI systems can be simulated. So that's the coolest thing about the community. Now, say that you are into robotics, you have very advanced simulation systems like Gazebo. So you can build everything inside that simulation, including physics simulations. So you don't have to worry about building a robot and spending. To be honest, like building a robot that we just showed you, it's like a lot of amount. I mean, it's a large amount that we cannot. I mean, university students are difficult to may find difficult to find funding for. But you can do the same thing in a simulation environment. So take use of it. Most of these tools are free and open source as well. So you can use those things and build your environment and build your algorithms and everything. And then once you are confident with your solution, you can go for an actual build of the robot. And same thing for sensor networks as well. You don't have to go for the most expensive sensor system when you're starting up. What you can do is you can go for a simulation system, or you can mimic or emulate the same system by a low cost system and get the work up and running. Right? Get everything, get the pipeline ready, and make sure that your logic works and your concept actually is usable. And then from that point onwards, you can build upon using the actual hardware. Even in the industry, sometimes we do that, because at the first level, we are not getting all the hardware to the point and start building up, because we have to validate everything. Because if the core part lies on the AI part, we should focus on that part.
Yes.
Because we can emulate the rest of the things. We know that those things are deterministic, right?
Yes.
We can get the inputs from the sensor. We know what we are going to get, and what we know that when we give an output, it's going to work, right? So similarly, what we can do is we'll emulate this environment and then build your core AI component and see if it works, and if it works, go for an actual implementation. That's my suggestion for that. Ishara, do you have anything else?
Yes, Ishara. Can you also give us a brief about where this physical AI is applied in the industry, and also how students would who are like to come into physical AI would grab things up?
So in addition to what Kanishka mentioned, so now we have open source frameworks, and also we have some free APIs that students can use to build these applications. So I think now is the best time, and start now, start small and build applications and iterate fast.
So thank you, Kanishka and Ishara, for that wonderful and amazing session that you all conducted. And so hoping to see you all again. Thank you.
Thank you.